All right. So, two sets of data we're comparing. We're used to this, right? We're used to seeing a table with x values and y values. That's a comparison of two sets of data, where each input has exactly one unique output. Now we can think about input and output in a very simple way. Input, we can write right under it. Input, we're talking about x values, and our output is going to be y values. All right, so when we see a table with x values and y values, we know that that also means that we've got inputs and outputs for our function. Now there's three different ways that we're going to see functions, at least at the beginning here, and how we're going to have to identify them. So the first thing we may see is ordered pairs. So with ordered pairs, we're going to look at one example and one non-example here of what a function is going to look like from an ordered pairs perspective. So if we have the ordered pairs 2, 1, 3, 2, and 4, 3. Essentially what we're looking for here is a repeated x value that has a different y value. All right? Now this is going to be something we'll talk about in a couple days, but it's all right if you have repeating y values for different x values. We're not going to get confused with that. We'll talk about that once we look at more graphs. Basically what you're looking for is repeating x values and making sure that they have different y values. That's going to tell you this is not a function. Do we see any repeating x values here? Are there any multiples of our inputs? No, we've only got 2, 3, and 4. Right? 2, 3, and 4, those are all our inputs. And then our y values, 1, 2, and 3, those are all our outputs. So for this one, we've got no repeating inputs. With different outputs. Therefore, this is a function by our definition of a function that we just established. So that's what we're looking for. If you see the same x coordinate twice, your brain should go, oh, that's weird. That might not be a function. And then you look at the outputs and see if you have different outputs, that's definitely not a function. But this one is. Each input has exactly one output. Everything works together, right? Now let's look at an example of some ordered pairs that do not form a function with a non-example. Basically just an opposite example. If we have the ordered pairs 2, 1, we got 2, 2, and we got 4, 3. Now, what do we notice here that we don't want to have? Jordan?
Repeating.
Yeah, we got repeating inputs. We've got 2 of the same x value, right? 2 and 2. But those inputs gave us different outputs, right? We had the same input here of 2, but it gave us different outputs. So this input and this input, we've got the repeating inputs here. What's that? Oh, it says repeating inputs. We're going to say different outputs. Therefore, this is not a function. And for those of you who already sped through the IXLs this morning, you may now be going, oh, this makes sense. I just look for the repeating x values and I know that it's not a function. Right? So if you use your critical thinking skills, you probably could have got through this IXL in like 5-10 minutes. But after the notes, it'll only take you like 30 seconds, 45 seconds maybe to finish the IXL. So we'll see. So that's what we're looking for. Repeating x values, different y values. Or repeating inputs, different outputs. Right, Brandon? Right. Now, we're not only going to see ordered pairs, we may also see mapping diagrams. Here's this part. Mapping diagrams. And a mapping diagram is going to look like this. Let's get our example. Got a little box here with a 2 and a 3 and a 4. We got another box next to it with a 1 and a 2 and a 3. We're going to call the first box our inputs. Second box our outputs. Same exact points that we just used in our ordered pairs. 2, 1, 3, 2, and 4, 3. Now a mapping diagram it's literally just a table that was split apart, okay, into 2 little boxes. And what we're going to map here is we're going to map an input to an output. So we're going to draw a arrow from the input of 2 to its output of 1. I'm going to bring this down here. We're going to map an input of 3 to an output of 2, and we're going to map an input of 4 to an output of 3. So this is what you're going to see with a mapping diagram. And once again, we see that each input has a unique output. We put in a 2, we get out a 1. If we put in a 3, we get out a 2. If we get out a 4, if we put in a 4, we get out a 3. None of those inputs are repeating, therefore this is a function. Something I want to point out here that's important. We don't necessarily know if this is a linear function or not. Okay, we've been dealing with linear equations, which is just another way of saying linear functions. But we could have something that's a function that's not linear, like this. If we have a graph, right? The graph of this, okay, this is a function right here. Is that a straight line? This one here with the arrows? No, definitely not a straight line, and yet it is still considered a function by our standards that we're talking about here. We're not going to get into anything too crazy like that, I don't think. Actually, yes, we will, because I think it'll be on the test. But we got plenty of time before we get to that point. So it's not necessarily a linear function. We just know that it is a function. Each input has exactly one output. Now, what would a mapping diagram look like that is not a function? Let's take a look at a non-example. We've got 7 and 6, and then we got 2, 1, and 0. Once again, with our inputs on the left, outputs on the right. And then we're going to map the 7 to the 2, the 7 to the 1, and the 6 to the 0. So just like that. So we can see here that an input of 7 into whatever machine we're working with here, whatever equation this is, if we input a 7, we're going to get out a 2, or we're going to get out a 1. Now that right there, that's the red flag we're looking for. We've got one input with different outputs, right? We've got a repeating input. If we wrote this out, we'd have 7 and 2. And we'd have 7 and 1. So the number's not repeating with these mapping diagrams. What you're going to see repeating is these arrows, okay? If we put a 7 into this machine and get out a 2, we can't then put a 7 in and also get out a 1, right? I always like to think of this in terms of baking. Anybody here like to bake at all? Or cook? Anything close to that? A couple people? So let's say you're going to make brownies, right? You make your brownie batter. It's all nice, ready to go. And then you put the brownie batter into the oven. What do you get out of the oven when the timer is over? You get brownies, right? What would happen if next time you got your brownie batter all ready to go, you put it into the oven, and then when the timer beeps, you pull out cookies? And you're like, how did that happen? I put in brownie batter. How did cookies come out, right?
I would talk to God.
That's right. Something mysterious is going on because that would not be possible, right? That's exactly what we're talking about here. Think about 7 as the brownie batter.
I think
right? Hold on. We put this 7 into the oven, this brownie batter, and the first time we get out brownies. That's exactly what we want, right? But then the next time we put in the same exact brownie batter, now we get cookies out. That's a different output for the same thing we put in. That's not a function. Does that make a little bit of sense? Kind of? Okay. So if we put in the 7, we can't get 2 different outputs out. Let's see, we can say that we've got, or this input's the one that's repeating. So we've got a repeating input of 7. Therefore, this is not a function. Almost done here. Last quick thing we're going to talk about is graphs. It's not going to be crazy. So we may also see these functions represented as graphs. Okay, and I'm specifically talking about our IXL. Go ahead and sketch this quick little graph. It doesn't have to be perfect. In fact, I don't want it to be perfect. I just want it to look something like this. So I'm going to move this down just like that. This should be good. So with this graph, our x-axis is our inputs, and our y-axis is our outputs, right? Just like with the other ones. X equals input, y equals output. Now take a look at this graph. Does each input to this graph have a unique output? Yes, it does. If we put in the 1 here, we get an output of 1. If we put in 2, we get 2. If we put in 3, we get 3. If we put in 4, we get out 4, right? So here's what we're going to write, because this is what we're going to be looking for on graphs. There is no points on top of each other. Therefore, this is a function. Why would we be looking for points on top of each other? Jordan?
Because that would mean they would be repeating.
That exactly what would be repeating, the input or the output? The input, exactly. If we take a look at our non-example here, and then we'll be done. Let's sketch one quick more little graph. 1, 2, 3, 4. 1, 2, 3, 4. Now we've got something that looks like this. So if we have a graph like this, we can see that we've got 2 points here that are on top of each other. Now, by that I mean they're in line vertically on the y-axis, right? So if we took a ruler here and we were dragging it along this graph, look, there's a point where we hit those 2 points at the same time. Interesting, right? So for this one, we've got 2 points directly in line with each other. Therefore, this is not a function. Yeah, you can see those are lined up correctly. So take a look. These 2 points right here on this graph, they line up at the exact same input, right? There's our repeating input. But they line up at different outputs on the y-axis. So those 2 points are what make this entire graph now not a function. So what you should be looking for when you see these graphs is 2 points that are directly in line with each other vertically. That tells you right away, boom, we don't have a function. Okay? Even if it doesn't form a straight line. In IXL, you're going to see some of these graphs, the dots look pretty spread out, kind of like a scatter plot, right? What you're looking for is 2 points that share an x coordinate. That's what I mean by they're on top of each other. They're directly in line with each other vertically. That's not going to be a function. All right? Any questions about these three items we looked at? Ordered pairs, mapping diagrams, and graphs. Okay, once you guys see the IXL, I know it kind of might be a little bit confusing right now. Once you guys get to the IXL and you see what's expected of you, it's all going to click and it's all going to make sense. So go ahead and get logged on to IXL, start BB1. We're going up to 80, folks. Not 60. There's no extra credit for 100, nothing like that.